Hello everyone. Today is a very special day for me because this is my second time at PyCon Hong Kong, and last time I was single, and this time I've come up with my wonderful husband who's sitting right there. He's come to cheer me up. Okay, so we'll get started. So firstly, we'll divide the session into some sections for installation. So if you can see my screen, I've posted a GitHub repo, github.com, Hemangi OpenTelemetry workshop. Please could you go to this repo, and if you just scroll a little bit down, you'll find the README section. So please follow along the steps. For this, you will need to create your GitHub account. If you already have your GitHub account, okay, I just zoom this link. So if you have your GitHub account, just log in and clone this repo. The link is mentioned in the README file. This is the link.
So checking something.
Did everyone manage to get to this web page? If you have managed to get to this web page, the next step is to create a GitHub account if you don't have one. If you have one, then I'll proceed in some time. You don't need to clone the repo, just go to the GitHub page and log into your GitHub account. We are not going to install anything locally, we'll be using the resources on the cloud. For those who have just joined, please visit this link, and if you don't have a GitHub account, you need to create one. If you have, please log into it. and no need to clone it. We'll be using resources on the cloud. Is everyone done until this step? So I'll repeat for the ones who have joined just now. Go to this link. For this, you will need to log in to your GitHub account. If you don't have one, you will need to create. If you have one, kindly log in and hop onto this site. Once you are on this page and you have logged in, there is a fork button right here. I cannot fork this because it is my own repo. You need to create on this. So what I mean by forking is, say you're copying this, consider this as a page, and if you're copying this, so fork, you're creating another duplicate clone of it for it to be used. So just click on the fork button there. And also if you just scroll a little bit down, I mentioned these steps in the step 2. You have to first create on the fork button. And then GitHub will create a copy of the repo under your account. Say your username is Alan, so it will be replaced by github.com Alan, and then you can give the repo name. The repo name should be a unique identifier. You can name it anything. If you need any help, raise your hands, I can come. Is everyone done until now? Anyone needs help? Okay, fine. I think I'll take it as a yes and we'll proceed. Next step is to open the project in GitHub code spaces. So what do I mean by that is, your setup will look something similar to this. Click on this green code button and here hop on to code spaces and you can click on create code space on main. So once you click on this, you will be redirected to a VS Code which is hosted on the cloud. It will take some time for the container to spin up. Like if you can see towards the right bottom, it is setting up the remote connection. I'll repeat this step again. Click on the right button on GitHub and under code spaces, there will be an option create code space in main. You can click on that and you will be redirected to a Visual Studio setup. Does anyone need any help? Yeah. To give you a gist of what we have just done is, I have set up a dev container and I have used code spaces. So a dev container will use VS Code extensions to download all the development bundles that are needed for our project or code to run. So we don't have to install anything on our local machine. if you don't believe me, you can just hop onto this port and click on this address, and you will see your container is hosted here on the cloud, GitHub. So this is where in the cloud we are accessing. You can see this is the same URL. So this is where your application is hosted. Is everyone good until now? Okay.
Why is my port different from yours?
Yeah, port numbers will be different. Just the second port 8080 will be same. The other port will be different. And even the container names, you will have some unique container or code space name. Mine is crispy Fortnite. You will have some randomly generated. And if this terminal does not hop up on your screen, click on this sandwich 3 buttons and click on terminal and new terminal. Are we good? Proceed. Okay. So a little bit of theory before we get started. So this workshop is about OpenTelemetry, and this is going to be a hands-on guide to observability. So what comes to your mind when I say the term observability? Anyone? What do you mean by observing something? No guesses?
Check how a request,
Mm-hmm.
the flow goes, and how different components provide logs or the latency of each endpoint
Yes.
through the whole process.
Yes. What you have said is right, but in a general context, to observe means to see or notice. So, from a software standpoint, what we are going to do is we are going to observe the system now. So, observing the system, so say if I ask you to observe this item, you can observe as many things as you want. But here, we are going to observe only the things which are required to us. That's what an observability tool does. So in terms of a software system, a well-defined software system has various non-functional requirements like usability, scalability, maintainability, availability and security and so on. But these three aspects, availability, reliability and performance, these make up the stability of a system. So how do we determine the stability of a system? That is, how do we say the system is stable or unstable? We do that by taking certain measurements of the system at regular intervals of time. So observability can be mentioned as the process of determining the output state of the system using the internal state and the output measurements that we are taking is known as observability. Also, many of you must have worked on some monitoring systems and observability systems. So you might think, okay, what is the difference? So the main difference between a monitoring system and an observability system is that in a monitoring system, we don't use traces. I'll explain what is traces. But in a observability system, we use something known as traces. That is the main difference. So there are three pillars of observability. So whenever you say you are trying to observe a system, you will try to observe through certain output measurements that I just mentioned. So you will take into consideration firstly logs, secondly metrics and thirdly traces. All of these are very important and we'll know why all three are important, not like we can't do with just one. Okay, so what is logs? So I have posted the real-time log of my payment system. So logs are, you can consider it like an array of 1D events which tell you some activities happening at some particular point of time. So why can't we just build an observability system with just logs? Like why do we need the metrics and why do we also need traces for our system? This is because logs, we are not able to aggregate the logs. So by aggregation, what I mean is, I can't say, can you tell me how many requests failed in the last 5 minutes? How many APIs failed in the last 30 minutes? And it is very difficult to spot a pattern or trend because the logs are unstructured. Some functions can have a print statement just as a log, some do not have a format. Your Excel, you are able to format it because it is structured. It is very easy to do aggregations or some computations in Excel because it has a structured format. Whereas a text document, it is very difficult to process. So same is the case with logs. The logs are up to a developer. How do you define it? So some logs can be structured, some are unstructured. Okay. Now what are metrics? So this is an example of what is a metric. So these are point in time values at a particular time. So the image above shows the load generator, CPU usage that the load generator has done at a particular time interval. Now why can't we just build an observability system with just metrics? Why are logs and traces also important? This is because logs do not provide full context of the system. That is, metrics can tell me number of users that were not able to access the system or what is the CPU utilization, but metrics won't be able to tell me which user was not able to log in. Or it won't be able to tell me, okay, this error occurred before this error or after this successful event. They don't have a particular sequence attached to them. This provides the entire system you're not able to view. For example, you may spot an error which may not show up in a metric. And you may also not know the sequence of error. At what time or after what event did that error happen. Now coming to the most important metric of observability, that is trace. So this is not included in any of the monitoring platforms, but it is included in observability platform. So what is a trace? If you look at the image, a group of spans make up a trace. So just like atoms are fundamental elements of anything, span is a smallest unit of operation in a system. So here, if say you make a GET request or an API call, so a trace consists of number of spans. So trace is the parent and span are the individual entities in it. So it will tell you how much time did your code took, how much time did the database connection take, or how much time did the server take to respond. And all of these together will make up a trace. Okay. Now coming to OpenTelemetry. So this is the basic architecture of OpenTelemetry. So basically, if you look, the collector is the core logic of OpenTelemetry. Say from here, you're processing. Say from here, you're giving a large number of requests. The collector's job is to receive the request, process the request, and export the data to some backend. So you are emitting certain events. So say you want to capture what happened during the function. You are trying to observe the system. There is a Python function you have written and you want to observe what is happening in it. So firstly you will receive that event and then that event is processed and that event is exported to a backend. So why is exporting important? And that backend could be your system terminal or a console output or a UI or a dashboard, anything. So OpenTelemetry provides, it is backend agnostic. It has integrations with different backends wherein you can go and integrate your backends and visualize the output. Okay. In terms of observability platform, you will always hear this term known as instrumentation. So what is instrumentation? To observe the system, to a Python code will be adding a piece of code. So that is known as instrumentation. To the existing code, to observe the system, we'll be adding certain code to monitor its behavior or analyze its behavior. So this process is known as instrumentation. Now there are different types of instrumentation. One is manual instrumentation, automatic instrumentation, and programmatic instrumentation. So what is manual instrumentation is what we'll be covering in this workshop. We'll be adding code snippets to observe our system. This will be very different from the Python logic that we have. This will be purely related to observing how a system is working, what API is taking what time, what is the response code, did it meet with an exception or not. Automatic instrumentation and programmatic instrumentations, OpenTelemetry provides certain modules that we can import, and on behalf of us, it will provide that instrumentation. So instead of writing 5 to 10 lines, we just need to import 2 lines or 3 lines, and the rest will be done by OpenTelemetry for us. That is known as automatic instrumentation. And then third one is programmatic instrumentation. So by programmatic instrumentation, there are certain libraries in Python which have already included in observability tools into them. For example, if you get a chance to visit request library, the code of request library, the source code, they already have instrumented it. So that is programmatic instrumentation, that the library itself already has added to it. Okay, so yeah.
So you just mentioned that we can use the automatic instrumentation, right? So in that case, won't there be a lot of traces that emitting from?
Yes, exactly. So the pros and cons are when the system provides, or when we are using a library that provides something, we have to go with the rules that the library has laid out. There is less scope of customization. So when you want to tweak the code, it is always better to go by a manual way. So
please continue. Just go. We will handle that.
okay.
Yeah. We will handle it. So just.
Okay. Yeah. Can continue?
Yeah, please.
So to also answer your question, say if I want to buy this phone, this is provided by a company. So I have to look out in the market and find whatever features fit to my requirements. But say if I want a feature which is not there, there is no option if there is no phone. So in that case, I'll use manual instrumentation, because now me being a developer, I'll have the advantage of adding bits and snippets to the code as and when required, and where to instrument it. So I'll have a programmatic control over it. So that's why manual instrumentation sometimes, or most of the times, I have used in production. We rarely go with programmatic or automatic instrumentation, because it leads to a lot of logs, and then we have to follow along the process of deleting the logs on the server. It takes a lot of storage space. Okay, so like I mentioned, we'll start with the exercises immediately in 3 to 5 minutes. In our code, we'll be using 3-4 lines. That is, we'll be instrumenting the code. I'll code along with you, but for the time being, I'll let you know this is the first import statement we'll need from OpenTelemetry import trace. Before that, if you just you say where is OpenTelemetry, we didn't install it. So if you get a chance to open our dev container that you just pinned up, there is a JSON file in dev container. We have installed OpenTelemetry API, OpenTelemetry SDK already. So this has been installed in the container itself. So nothing you have installed locally. So the first step to use OpenTelemetry is to install. And why do we do PIP? Because Python, OpenTelemetry is not a Python native library. It is an external library. So you need to have that library on your system to install it. You'll be like, why don't we use some function like time or so? Because time library comes default with the Python package. But this library is not a part of Python. It provides support for Python, but it is a completely different library. Okay. From OpenTelemetry, import trace. So this is our first line that we'll be importing in our code. So what is the purpose of this? So it refers to the OpenTelemetry API for tracing. It provides interfaces for creating and managing traces and spans. So in the previous screen I showed, we just installed OpenTelemetry API. So this comes from telemetry import trace. It comes from the API package. And if you notice, there is a word name interfaces. So what are interfaces? So if you understand, there is the dictionary meaning of interfaces is a place where two unrelated systems come together and communicate with each other. To explain in simpler language, consider this guy Alan, who has fallen in love with Lana. Alan knows French, Lana knows English, but they are unable to communicate. So now, Alan being a guy, what he does is, he finds a friend, Stan, who knows both French and English, who is able to understand both. And now their communication is possible. So in this case, Stan is an interface between Alan and Lana. Because this is a point at which two different systems are coming and communicating with each other. In real world example, a USB port is an interface. Your mobile phones have different operating systems and hardware. Your computers have different operating systems and hardware. But they are still able to communicate with each other using USB. So it is an interface. So coming to our previous definition, we are able to, like if you look at the definition, it provides interfaces for creating and managing traces and spans. What I mean by that is, this is the point from your Python code through which you will be able to access OpenTelemetry and vice versa. From OpenTelemetry also you will be able to access Python, and from Python you will be able to access OpenTelemetry. So that's why we are calling it as an interface. Yeah. The second most important import that we are going to use is something known as a trace provider. If you look at the coding conventions, it is a class. Because if you look at the casing, previously and now, T is capital and P is capital in the trace provider. It is a class, so we are going to instantiate, and like the name says, tracer provider. It is going to provide, or it is going to create traces in the application. And the third most important import, for this example, we are going to be exporting the logs. That is, the output is going to be shown where? By exporting, I mean, where is the output being going to be shown? It is going to be shown on your console. You can also export it to other platforms like Grafana, Jagger, or say some UI dashboards. But in this case, to maintain simplicity and for the time constraint, we are going to be exporting it to the console. Here you will see two imports. One is a simple span processor, and second one is a console span exporter. So if you notice, we had one diagram wherein we mentioned the architecture. You are going to receive some data, and then you are going to process it, and then you are going to export it. So this is where the processing or the span processor, simple span processor comes into picture. It is going to process the span immediately. It is going to receive a span, process it, and send it to the output. Second span it is going to receive, we are going to process something, and then we are going to export it. Now there are different types of processor too. There is a batch processor. It will collect all the spans, process it together, and then send it together, thereby reducing network calls. But to maintain simplicity, we are using simple spanning processor. And console span exporter, it is the next step. That is, after processing is done, it will be, the data is going to be exported to a console or the terminal which we have. Okay, so let's get started with GitHub. I'll code along with you. Anyone any questions or need some help in setting up? Because we'll be doing 3 exercises, and after the 3rd exercise, we are going to be instrumenting open source popular library, requests library from Python.
Okay, if you guys have any questions, just find the do search guide. It will help you for the questions.
Okay, so let's get started. So hop on to the code space that you have created. You also have a GitHub Copilot access here, which I don't think we'll be needing.
Enlarge it.
Yeah. Just pull it up.
Yeah. Close up again.
Wait, I close this. Is it visible, or shall I increase the font?
Maybe a little more.
Little more? Okay. Minimize this to So we'll get started. Firstly, we'll begin with a very simple example of a calculator function or a multiplication function which we'll start. Before that, I'd just like to know, you might wonder what version we are using or what development dependencies have been bundled in this container. Where is the container? If you see the bottom, if you scroll to the bottom left, blue color button, here is your code space. And anytime you make a change to this dev container.json, you need to rebuild this container or your code space. I'll show, but for now there is no need to make any changes here. So let's get started. We'll begin with a very simple, just like a hello world application is done for any programming language. This is a bit similar. We'll begin with the first exercise. So just click on this new file and create a file, calculator.py. So what we'll start doing is, we'll create a multiplication function and we'll instrument it. So first we'll create the function without adding any instrumentation, that is without adding any OpenTelemetry code. Just give me a second, some access code. Sure. So like I mentioned, the first import is we need to connect to the OpenTelemetry system. So what do we need? We need an interface here. So but before we write that, let's get started with our multiplication code. Okay. So I leave some line for imports and def multiply, and I'm taking 2 integers, a comma b as input, and the simplest multiplication is to return a star b. Fine. Now I'll create a main block wherein we'll add the function.
So you can enlarge the font a bit again.
Okay. Is it fine?
Yeah, I think this is it.
Wait, I'll close the terminal. This will enhance the font. we are working with a very simple function which is taking two numbers or two variables and it is multiplying. I'm creating a main function. For the time being, I'm keeping these numbers as static. Say I'll keep A is 3, A is 5, and maybe I'll print the result equal to, I'll call this multiply function by passing A comma B. Okay, now I just see if this is a direct execution. You can directly call this multiplication function if you don't understand this logic. So basically in this snippet what we are doing is, if we are running this code from the same file, this condition will evaluate to true. The name of the module will evaluate to main if we are running the code from the same page, that is the same module. Okay, this is a basic Python code. Everybody is up to here? Yeah. Just open the terminal. Now let's run. Do Python. We'll run this Python script. Calculator.py. Okay, wait. I need to print the result. Just print the result. Okay, so if we are printing the result, I'll just do calculator. We got the result as 15, right? So now let's start instrumenting this code. So firstly, to instrument, we need an interface, like I mentioned. So the interface comes from OpenTelemetry API module, like I mentioned. So what we are going to do, we are going to instrument the code. By instrumentation, I repeat, we are going to add some code to our existing logic that will help in observing the system. So from OpenTelemetry, firstly we'll import something known as traces. This will help us to communicate with the OpenTelemetry in Python. Actually, I think it is trace. Okay. Now we need something known as the trace provider, like I mentioned. The three imports that we mentioned are much needed. From OpenTelemetry .sdk.trace. See, you don't have to learn this. These imports you will find on the OpenTelemetry.io website. You just need to copy, because this is a protocol that is defined by them. So we are just going into the package and importing it. There is nothing like some logic that we have to build around it. Tracer provider. See, you're getting type hints. Okay. So we have imported the tracer provider. And the third thing, you have created a trace to interact. Secondly, you have created a tracer provider. Thirdly, now you need some exporter to export and process, like I mentioned. OpenTelemetry.sdk. Export. This actually represents the file path in the library if you have. Import console span exporter and simple span processor. Also, if you're not able to follow along or type, if you go to his app and main.py, you'll find these 3 imports, line number 2, 3, 4. Just simply copy. If you're unable to follow along or type, under this app folder in the main.py file, you will find these 3 import statements. First is the interface, second is the trace provider, which is useful for creating a trace, and third is the exporter and a processor. That is, will be whatever is the output will be shown here in the terminal, that is the console for this application. The next step, what we are going to do is, we are going to set up a tracer. Just copy these 2 lines. And paste. If you change the order of these lines, the code will not work. Reason being, the set tracer provider, it is going to instantiate once and it will create the instance, and the get tracer provider is going to get that instance and it is going to configure it. That is, we are saying get this instance and configure the logs to the terminal. So if you try to configure something that doesn't exist, it will run into an error. So you always need to create first and then do some operations on it. Otherwise that entity does not exist. Once this is done, if you go to your main.py file, you just kept this boiler code, and this is going to be common for every application or anything you will start manually instrumenting. The trace interface or the trace module, which helps us to communicate with OpenTelemetry, we are going to get that tracer which is defined for this file. So what it is essentially saying is, get the tracer which is defined for this file. Now if you look at the code, this from line 1, 2, 3, 4, 5 until line 8 is very common. You just have to change the imports or where do you want to export. So 1 to 8 is a by default. Consider you have to use it every now and then when you are trying to instrument a code. The only logic that you have to apply is, where do you add a span now? So now I want to look at the way how this multiplication function is working. I want to observe this multiplication function from a system perspective. So your span should be inside the multiplication function, right? So we are going to open a context manager. So anyone, what is a context manager, or need some help with a context manager? Okay, context manager will help to manage resources. So anything that starts with a with block in Python is essentially a context manager. It will create resources for you. It will manage resources. Say if your program runs into an error, the context of the span is eliminated and the span is closed. If you have a database connection inside a context manager, if some error occurs or some electricity goes down, your connection is closed. If you have a file inside a context manager, your file is safely closed without the programmer mentioning file.close or f.close. So it is helping in managing the resources. So if you go to main.py, so this is the way, this is a context manager. Just simply copy it with tracer, and this is a function that is defined start as current span. Like we saw in PPT, just go a little behind. A group of span makes a trace. Now we are starting a span now. in this function. And you can name the span anything you want. Just name something that you will be able to identify yourself. I'll name it multiply span. So when we ran this function initially, so what was the output? Just 15. Now I have added some, not all, but some part of the instrumented code here. So let's run and see what output do we get. Very important output. Okay. Getting the output is important, but understanding output is more important. Okay, it is giving something known as, it is a dictionary that I am getting, or a JSON format that I am getting. The key is name and the value is multiply span. It is the same name that I mentioned in the code, right? Also we are getting a context. I'll explain what is a context. This is a trace ID. A group of spans make up a trace. This is a unique identifier, just like a primary key or just like a roll number which can be unique, which cannot be shared by multiple people. This trace ID is unique. This is a span ID. This is given by the OpenTelemetry. We have not done anything. We are just using it. It's just like somebody has created a fridge and we are learning how to operate it. We are not creating a fridge here, but we are just learning how to operate it. Okay, it is telling what kind of a span it is. It is saying it is an internal span. That is, it has to do, it doesn't have to do with the server processing, but it has to do with the internal logic of a function. Does it have a parent? No. Spans can be nested. It can have a parent-child relationship as well. And also if you see, the function start time is given and the end time, the timestamps are given. And what version of telemetry it is using, what telemetry SDK it is using, all these are mentioned, and after that you get an output. So what we have done is, we have instrumented a code little bit. Now there are different levels of instrumentation, you can keep on increasing. Say if I want to print what is coming inside this, like what is the value that A has, because say if my function, this product I am saving to a database, and if I run into some errors, the value is not matching, I need to know what value of A went inside. So in that case also we can use set attribute function and it will show up in the logs. Now our logs are showing up in this terminal because we have configured it to the console output. We can also configure it to some backend or some dashboard. Pydantic Logfire, Grafana, Jagger is some exporters. What it will do, your output will not be shown here, instead it will be redirected to some UI dashboard for a good visual view. So this was a very simple calculator function. So is everybody through with this? So we'll build on it. Okay. So the next thing, I have a task for all of you guys. I want you guys to create a divide function and instrument it. Just like we did it for multiplication, let's instrument the code for a divide function. I'll also code along with you, so don't worry. So like I mentioned, until line 8, everything remains same. And firstly, don't rush into adding instrumented code. Write the actual Python code, make sure it is running, and then add the instrumented lines. Just like this multiplication function, let's start with some function divide. Maybe I'll use two variables, x comma y, right? And I'll return x upon y. Okay, this is a function which takes two variables as input and returns their division. And inside main, we'll add just divide. We'll add something like 15. If you look at my code, instrumentation or spanning is not added. So the output is going to be a normal Python output here. Just add this clear command so that our terminal is blank, and we'll run this script again. Okay, so my two numbers were 15 and 5, and the result of division is 3.0 because Python returns a floating value in division. It does not return an integer. Is everyone done until here? So let's start instrumenting this code. So what do we need to do? We need to add a current span here, just like the one which we added with a context function. And since we are trying to observe this divide function, so where do we add the span? We'll add it inside the exact core logic of where we want to view how this divide function is working. Just match the indentation and I change the span name for simplicity. This is a very user defined name which you can give. Can we run this? Anyone needs any help? Very good. Okay, we'll run this. Okay, this was the output when there was no instrumented code. Now, this is the output when we have instrumented. Okay. But you might say this function is similar, so why did I take this, for example? So I want you to see the magic of instrumentation. Now when we are going to intentionally run this code into some error, now we are going to divide by 0, which is not allowed. So in my code, I am going to set b as 0 and let's see what will be the output. If I run this again, and I have made my second integer, that is the one that I am dividing, the big one, that is 0. Okay, no doubt it gave me an exception and the stack trace, which Python also gives me. But if I look at my console output, you will see under this divide span, you see the status code. Has run into an error and it has given me a description: 0 division, not allowed, and also it has given me a stack trace, and there is a very important key here, exception escaped, which is set to false. That is, I have not handled that exception here. So now your third task, is everyone done until here? So your now third task is to handle the exception. So in Python, how do we handle the exception? Using try and except blocks, right? So add some try and except blocks under this divide function and see how does your OpenTelemetry data behave. Also, if you want, like in a normal programming language, if you want to see the logs, what we'll do, we'll use a logger library and we'll see what is X, what is Y. That can also be done. So how do we do it using OpenTelemetry? In this context manager, we tracer start as current span, add a span, like a descriptor, that's what I mean, and do span dot set attribute. Okay, what do you want to call your first attribute? Give your user defined name. I'll say this is the user input. And what does it denote? It denotes the first user input that I have given. User input, and this names should be unique. So I'll give it user input dot x. And second, if I just want to set attribute, I can add the user attribute, or I can say user input dot y. So what will happen in your output when you run this program? You will have these keywords, user input dot x, and what value of x was supplied to the function will show up in your output, and what value of y was supplied to your function will also be showed here. Also, don't forget your task, add exception handling here. Once you add exception handling, you will notice exception escape will not occur because you handle that exception in the code. So just like set attribute, there are different types of attributes that you can set up on the span. That is, these are events that you are emitting and your collector is going to collect them, process them and send to a exporter. And it is known as manual instrumentation because you are manually writing it. The library is not doing. There is a lot of work to be done by the programmer. Let me try running. I have not added exception handling. I will just clear my terminal. Okay. You see these attributes, user input x, what was supplied, and user input y, what was supplied. And the reason we are doing this is, and we are not writing print statements or log statements because we are trying to keep a uniformity. Under this attribute dictionary, whatever attributes you want to give in the output, you want to pass to the output or some exporter that you want to view, you can send it to the attributes dictionary. Have you guys done with the exception handling? Add some exceptions. Now if you look at this piece of code, I'll add exception here. I'll add a try block. Okay. The purpose of adding exceptions is for graceful termination of a program. Say you end up on a website and you see zero division error, you will be frustrated. So your user experience should not be bad. You have to gracefully terminate the program. So let's accept zero division error, and maybe I can print division by zero, not allowed, or anything you want to return. Or so now in this case, the exception will be handled, so there will be a graceful termination. And this exception escaped field will be set to, like, it won't be there because it is coming under this exception log, exceptions track trace. So I'll run this. I have added attributes, I have added exception handling. So we are just comparing the outputs here. since the function I didn't return anything, the default return value of a Python function is none. So none is printed. And if you see, the exception was handled properly. Okay. Is everyone done until now? Can we proceed with the last? Yeah, sure.
Excuse me, could you please show the entire group on row 11?
Row 11? Yeah.
Yeah.
I've just,
Right, okay.
you can use this as any name here, which cannot be, yeah. So what we are doing here is, so on line 11, with block, here it will create a span, and before exiting the with block, the span will be released. The life cycle is managed here, the span. And whatever name you are using here, you are referring to a span here. So you can name it as span underscore 1 or span underscore 2 or anything. Span is not required. You can even refer to as any user defined name. Say if. So on that span you are setting that attribute. So make those corrections like whatever attributes you are making. Okay. And for those who have like not followed along this, the first multiplication exercise, if you go to my link, click on main, under exercise 1 you will find the code for the multiplication function. Under exercise 2 you will find the link for division function. Actually, I want to go through the third one too, but I think we are running short of time. So we'll go through one important exercise now. This is something I had to do in my own project. So these were some very simple building blocks that we used. But the current exercise that we'll start is, just give me a second. Okay. Most of you might have used a requests library in Python, right? So we'll try to instrument the requests library today. This is a very popular Python library. So your first step is to hop on to github.com psf requests.git. I'll follow along. psf/requests. I will just github.com/psf/requests. This is a very popular library, like from the stars you can see. And it's an open source library. Open source, that is, its code is readily available and I am able to make changes to the code. That's why it is open source. So now what I have to do is click on this fork. We'll create a copy of this. Fork means you are creating a clone of it and you will start making changes. Okay, so since I already have created a fork of this, you can create a fork. I just named it as request_tests. Create a fork of that library. Has everyone created a fork? Does anyone need any help? click on code and create code space on me. It will take some time to spin up because it is a bit heavy module. In my case, it is already done. Until this loads up, let's understand the workings of this request library. So this request library is used for making HTTP, HTTPS requests. Mainly REST APIs use 4 methods: get, post, put, delete to perform all operations on web world, web ecosystem. So if you look at the definition of the requests library, I'll show you in the source code until the time it is loading. This is a very high level overview. Whenever you use requests.get or requests.post, what it does is it internally creates a request object. First step is it creates a request object with the method, URL, and the keyword parameters or the headers that you have supplied to it. And the second step is it internally sends this prepared request object to the send method. Be it any method, you're using get, post, put or delete, it is underneath going to call the send method. So what we are going to do is, we are going to instrument this send method itself now. We'll understand the time it takes for execution, we'll understand how it works. We'll add a span to this send method itself. Have your code spaces loaded? Okay. So if you take a look at our directory structure, we have used this OpenTelemetry dev container to install OpenTelemetry. Maintain the same structure, create a dev container in the code spaces. The reason we are adding this again is because it is a complete different container. Add a folder, .dev container, and add a JSON file to it. Dev container.json, and simply copy the dev container.json file here because we are going to use the same packages here. And just on line number 12, let me increase the font. We don't need Flask, but what I want is, I want this container to install the request that is present on my local system. So what I'm going to do is, under this line 12, I'm going to add pip install -e /. That is, -e stands for editable mode. So whenever I'm making changes to this source code, it should allow the edit mode. I don't have to rebuild this container. Example, if I use any of the libraries in this request module in say 1 version, and if I make some change to make it to a 2 version, the container will have the first version. Then I'll have to rebuild it. So to allow so to prevent rebuilding a container, I'll add this flag, editable mode, and /, that is in the current working directory. Allow me to install this in the editable mode in the current working directory. This is the only change that is required. You can keep the Flask as it is, but it is not required, hence I have removed it. And also forward ports is not required. So if you want, you can keep it or you can remove it. Okay. So we are going to do a global search. Since we are going to hit a .get endpoint, so let's, and like I mentioned, the life cycle of any requests library is, it is going to call this send method. So let's search for this send method in our source code. So def send. So this is the definition of the send method that we have. Okay. So since I have gone through the code, this send is the one that has the core logic of the exact send one. The other send, they are just simply calling and adding some layer to it. But the main logic is present under the sessions.py file. Okay. Under the source directory, under request, under sessions, you will find this send method. So if you just take a overview of this is where the exact request is being sent. Now how do I know this? This is because I have worked extensively on the requests library. So now what we have to do is, we need to instrument this code. This is the working code of request library. So I know for a fact it is going to work. I don't need to test it. So now we need to add manual instrumentation to it. So again the same steps. Go to our previous container. The first 8 lines until import, simply copy it. And paste it here. Take care of the indentation. If you notice, in our this project, we need OpenTelemetry. So if you just change the order of installation of this, if you add request library before OpenTelemetry, this will run into error. Because requests, this is a request library, this needs this OpenTelemetry package first to be there. So make sure OpenTelemetry command is in the same order. OpenTelemetry is first, and then you have installed this request module. Okay, so first 8 lines we have added from here, and now we are going to start a trace here. With this, open the context manager. This is the main logic where it is calling the send function. So I am trying to observe the send function exactly, what it is doing. I know it is getting a bit heavy. But if you look, the steps are exactly the same. I am just pinpointing you to the exact line where you need to add the instrumented code. Okay, so let's add the instrumented code here. Let me create this known as send span and identify some identifier with it, and let us set some attributes on this. These are the exact 8 lines that we have used previously, no change. Now we are going to set up a few attributes here. What we are going to do? We are going to say span dot set attribute I want to print the method that is getting called while I am calling this send method. So I am going to name it. This is a user defined key, but I have kept it descriptive. HTTP method. And if you look at line 697, you already have a request object in this function. So this request object, just like you have objects, say book or a person, it has certain attributes. So request object comes with the attribute request.method. It is an inbuilt method. And the second attribute that I want to send is, I want to set the URL. So I can also say http.url. That is what URL I am trying to access. And if you look at line 697, there is already an attribute request.url. Just copy it. Just a minute. Sorry. You can add more attributes, but for the time being, I just kept this attribute only. Okay. Fine. Also, if you notice any problems in your code, you will find it under this problems tab. If there are any errors or if the libraries are not imported. Under this problems tab, it will show up. So for now, we are good to go. Okay, so now how do we test this? We have made changes. Now I need to make a URL call to make sure that our instrumented code is working properly and we'll able to observe this send method. So I'll create a file. Maybe I'll name it as testapi.py. Any naming convention is fine. It is at the root level. You have created at the root level. You can create it at any level, but while you are running that script, give the correct path of the script. So first step, I'm going to import the requests library. Just taking the request class. Now let's make an API call. I'm just using my phone just to check one valid API which I can call. Or I can even name it as a main function. I'll zoom in a minute after I type. Just give me just checking if the URL is able to access it. Okay. This is the URL. I'll paste it somewhere in the presentation. You can access it from here. It is http://bin.org.get. It is returning a JSON output, JSON response on the GET request. So, but we are going to access it using the requests library. So I'm going to import the requests library, give the URL, and we are making a GET call. So, GET to pass this URL. Just printing something, response status. So if this is at the root level. Is everyone thorough until now? Or if you need any help, I can come. So what we are doing, we are making a get call to this URL, and we have like any request call that you make, be it get, post, put or delete, it is going to internally call this send method. Now open the terminal, and run your code. But before running, make sure you don't have any problems here. PyCon test underscore clear.py. Okay, I forgot to run this code. Like the main function was not called. Just simply call the main function. Okay, just give me a minute. Let me see why it didn't work. Debugging. I think I built this container a long time back. Have you guys tried to run it? Is it working? Are you getting telemetry response? Okay, you're rebuilding it. Okay. Yep. Yep, you're right. I think I also need to rebuild it. Also, while it is running in the background, I have a mini quiz for you. Please take out your phone and could you scan this code? Scan this code or go to menti.com. Are all in? Can we start? If you are unable to scan, go to menti.com and use the code 37557592. We'll start, right? It's short of time. Also, please remember your names. Ready? The fastest one gets more points, so try to be quick. Who is Matthew? Okay, so I think we are running short of time. I'll upload the same code on this same GitHub repo with some different branch, and you can take a look or meet me outside. And I hope you guys had a good time. Thank you.
Any questions? Any questions?
Adding a tracer will it slow down the original logic?
Oh, I didn't get you.
So you add something to the span tracer texture, so will it like really very heavy and then the original logic will get slow?
Okay, will it slow it down? That's what you were saying. Okay, the overhead is very minimal here. The overhead, time complexity or whatever you say, the overhead it will cause is very minimum in this case, because it is a very lightweight library or SDK that we have installed in our system. And here, if you look at the code, we are not adding print statements, we are not adding logs, we are not using matrices. All this is being taken by OpenTelemetry. So even if there is some overhead, it is balanced by removing these log statements and using OpenTelemetry.